Welcome to the webinar from CANNA. My name is Peter Klaassen. I started in this industry in 1989. Since 2008, I'm the growth consultant of CANNA. Today's topic is EC. Nutrients are made from salts. If I put salt in water, you can see, for example, this element, potassium nitrate, is a solid salt. If I put it in water, it will dilute and it becomes two different ions. One has a positive electric load, potassium, we call it cations, and the negative electric loaded ions, we call them anions, in this case the nitrate. These elements makes electrons jump over from one side to another side in an EC meter. So actually with an EC meter we are measuring the speed of the electrons. But the more ions you have in the water, the faster it goes. But we can also count the amount of ions. We count them in parts, in 1,000,000 parts of water. So parts per million is also a unit to measure the EC. But every part has a certain weight, and that weight we can measure in grams. It's another unit. So if we consider EC as a measuring equipment, we can choose for different units. In Europe they use millisiemens per centimeters. Probably over in Canada you can use the parts per million, but more common sense is to use grams per liter, so you know how much nutrients is in a liter of water. Of course, we always dilute a solution into a bigger amount of water. We do it by milliliter per liter. Although we can measure the speed of it or the amount, it's easier to translate it in the grams per liter. Nutrients are made from salts, and a characteristic of salt is it attracts water towards it. It means for the root, for the plant, it's harder to take the water out of the substrate when the EC is higher. The salts in the substrate prevents the water from releasing it to the plant. But that's climate control, that's another topic. EC plus is the amount of mineral nutrients you put in the water, but it can also be the mineral additives like PK. So there is always a relationship between how much you dose in milliliter per liter compared to the contribution of the EC you measure afterwards. So the EC plus is the total sum of the EC which we add by the minerals nutrients or by the mineral additives. But there is another item which can influence the total EC, which is the EC of the water itself. Tap water can have a certain EC level. In general, soft water contains an EC which is lower than 0.4, and normal water has an EC level between 0.4 and 0.5. Nutrient companies in general make their nutrients on top of that normal water because it contains already some calcium, some magnesium, and a pH buffer called bicarbonates. In some cases the tap water has too much of these good elements. We call it hard water. It has an EC of 0.5 or even higher. Although the elements which are in are positive, it is too much. In some areas, often close to the ocean or sea, the water can contain, instead of calcium, it can contain sodium or chlorides, which are toxic elements for the plant. So the EC itself, that it is high, doesn't tell you the quality of the tap water. In general, we have to dilute these type of waters to a lower level to make it usable for plant growing. The total of the EC plus from the mineral, nutrients and additives and the tap water makes the EC total. That is what you measure in your solution. Every time you water the plant with a nutrient solution, you actually correct the substrate itself. So the plant is not reacting on your watering, the plant is reacting on the substrate. And in that case, I like to give you an example how that system is working. We call it the bucket story. For example, we have a 10-liter bucket. The EC you measure in the solution has an EC level of 1 gram per liter. And that means, because we have 10 liters, the total amount of nutrients in this bucket is 10 grams. If for some reason 7.5 liter is evaporating the bucket, what will remain in amount of water is 2.5 liter. But of course, the salt didn't transpire, it stayed in the bucket. So what does the EC become? 10 grams in 2.5 liters makes it in every liter 4 grams. So the EC becomes 4. Of course, we are not growing in a bucket, but we are growing in a pot. And in that case, we have another example. In case of a 12-liter pot, but is filled for 50% with water, so the 6 liter, and the EC level of the 6 liter is 3, meaning every liter has 3 grams, makes a total of 80 grams of nutrients in this pot. The plant is growing and transpiring. It's transpiring 3 liters out of it, so 3 liters will remain in the substrate. But the plant is also eating nutrients, 3 grams out of the substrate. So the total amount will become 3 grams less, so 15 grams is remaining. If the grower is willing to correct that situation, he starts to water. He starts to water 1 liter with an EC level of 1, because he sees the EC is rising in the substrate. Because of that, he gives 1 gram extra to the substrate. It becomes 16 grams, but he also makes the substrate a little bit more wet, and he brings it from 3 liters to 4 liters. In this case, my EC will become 16 grams divided by 4 liters, so it becomes 4. Although the grower was watering with a low EC, the EC was still rising. So the plant is living in the substrate. And the EC level in the substrate can influence the uptake of water, so makes it hard for the plant to transpire, which is of course climate control. Never overdose the substrate. But if you do overdose the substrate, what will happen? Well, as long as it's not that bad, in the substrate called Terra, in the beginning there are no problems. It is the buffer of the substrate itself who can hide this overdose. As long as you don't make that mistake too often, you will not see any problems with the plant. And although cocoa is a different substrate, cocoa can do the same, hiding some nutrient elements. We call it the cation exchange capacity. But when you go growing on inert substrates like rock wool or clay pebbles, and you grow in a run-to-waste system, hydroponic system, and the EC will increase, there is still a method to get rid of that overdose, and we call it drainage. So by draining more the substrate, you can flush actually the excess out. If you make use of a recirculating system, then you will see that if the plant didn't take the nutrients, the EC will rise in your reservoir. You still have time to compensate it, so you can dilute the solution, or you can take the whole solution out and refresh it. And in that case, you can lower the problems of overdosing in nutrients dosing. But how do I know that I have a problem with the EC in the substrate? Well, you can measure it. You can measure the solution from the substrate. In a recirculating system, it's quite easy. In the reservoir, you see that the EC will rise just by taking a sample and you know the number. For run-to-waste system, often you can suck water out of the substrate, or sometimes even by squeezing a little bit, and directly you can measure the EC which is in the root zone. But for organic substrates like cocoa or terra, it's not so easy, because actually you want to take the sample just before you start to water. But then the substrate is dry, it's hard to get that out. Some growers use the drain from those substrates. But if you use the drain, the number can mislead you. I will give you an example. On a pot, I like to give 1 liter of water. I can give it all at once, but by gravity that water is pressed downwards, so the water comes out is always a mixture from what you give and some from the substrate itself. If I water the same liter but in 10 waterings of 0.1 liter, what you will get is you watered but you stop. Now that water has time to spread more in the substrate. And then the next watering is coming, so little by little by little, that water is pushing the old water out. The drain you measure in this case is actually the numbers from the substrate. But watch out, because if you do this for 1-2 weeks, you will also see that the drain becomes very clear, clean. It means the water did make rivers in the substrate. And now you have the problem that when you water, that substrate will not absorb that water, so the drain you are measuring is actually the water what you were giving. But in some cases, it's still possible to use the drain water. In this graph, you see the day hours, 12 in this case, and you see the moist content of the substrate. When the night is starting, we don't give water. So in the morning, the substrate is actually very dry. Then we give water, but in the first watering, you don't see drain at all yet. The first water, the substrate will absorb. And then in the second or the third, the first drain appears. And that's the drain which is actually coming from the substrate itself. During the day, of course, you get your drain, but that drain is always a mixture of the water what you give and a little bit from the substrate. So don't use that one to correct your dosing to the plant. If that is not possible, there is another analyze method. You take a little bit of the substrate and by an analyze of 1 to 1.5, you can measure the EC number. Of course, you did dilute it, so you don't have the real number. But in a PDF we put also on our web page, you can find how to make that analyze method. Please have a look. If you measure the substrate and you were giving an EC of 1.3, then the number can be lower. For example, in this case, 1.1. What does that tell you? It tells you that the plant eats more nutrients from the substrate than it takes water from the substrate. So the evaporation is still low. In general, that happens often in the vegetative phase when the plants are still small. How do you correct it? You give a higher EC. So actually what you can read in the Grow Guide is in the beginning you always increase your nutrient dosing. But later on, for example, we still give 1.3, but you measure 1.5. That means the plant doesn't eat so much anymore or starts to transpire more. That means you have to compensate it by starting giving less nutrients. There is enough in the substrate itself. That is something what in general always happens in the generative phase. Have a look at the Grow Guide because you see in the second part of the flowering phase, you see we recommend a lower EC. Although a lot of growers think that with nutrients you can have higher yields, actually it's made by the light from the photosynthesis. First you have to make energy, and with that energy you can make anything you want. Leaves, flowers. But if you want to make the flowers, of course you also need nutrients to add to them to create them. But how do we bring that nutrient in? Well, in this case we have an example about a plant with enough flowers, so he can take all nutrients which you can give it. I give 1 liter, and that liter the plant will transpire. And with the liter you bring the grams into the flower. Because we give an EC of EC1, that means 1 gram will go into the plant. Another example is for 2 growers, but they have a different climate. One can water 3 liters a day, and of course he give it also with an EC of 1. But the other grower, his climate is not so active, so he can only water once with 1 liter. Although the same plant is standing there and needs the same amount of nutrients, he has to give 3 grams to get the same. Think about it when you are growing with LED. Often, because of the temperature, your climate, your transpiration is lower, so you have to compensate it by EC. We have a formula for that. And that formula is EC multiplied by transpiration will give you the weight increase. So the plant decides how much nutrients he needs. For example, in this case, you can see that the weight increase could be 525 grams. But the plant is transpiring through his whole growth cycle. He is taking water and transpiring. Well, if the growth cycle is 70 days, 10 weeks of 7 days, and per day he is transpiring 5 liters per square meter per day, that means that the average EC should be 1.5 grams per liter. Because the total of that sum makes it 525 grams. But in autumn, the temperature in general is a little bit lower, the moisture in the air is a little bit higher, so the plant will not transpire so much. Instead of 5 liters, he's only taking 4.5 liters per day. But the same amount of grams must come in the plant. So to compensate it, we have to increase the EC level. It doesn't mean you use more bottles of nutrients, you only dilute it in more, or in this case, less amount of water, because the total amount stays 525 grams. This was the topic EC. Of course, if you have any questions about this topic, don't hesitate to ask. We are there. Thanks for listening. My name is Pieter Klaassen, CANNA.